T minus 1 minute. T minus 50 seconds. T minus 40 seconds. T minus 30 seconds. T minus 20 seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Good day, future engineers. Welcome to the third day of your senior high school immersion. This is Mariana Ian, a third-year student taking up Bachelor of Science in Civil Engineering at STI West Negros University. Let's not put too many words because I know you're all excited to know more about engineering. So let us all welcome our first lecturer that will inform us all about the mechanical engineering.
Hi there! Are you interested in machines, technologies, inventions, science, and math? Or do you want to become an engineer someday? Also, are you one of the students who are still undecided of what course to take in college? Well, you're watching the right video. I am Trisha Grace P. Pontino, and I'm currently a second-year college student here in STI West Negros University taking up the course of Bachelor of Science in Mechanical Engineering. So for today, I hope you sit back, relax, and watch, listen, and learn. So for today, we're going to tackle about what mechanical engineering is all about. Its branches and the scopes and jobs that you could have when you graduate, and if you pass the board exam, of course. So let's move on to our presentation.
So once again, I welcome you all to the Mechanical Engineering Orientation. So we have three topics to be discussed in this presentation. First is what is mechanical engineering. Second is the branches of mechanical engineering. And then the last one is the scope and jobs of mechanical engineering. So what is mechanical engineering? It is a discipline of engineering that applies the principles of engineering, physics, and material science for analysis, design, manufacturing, and maintenance of mechanical systems. Its primary focus of this particular engineering lies with the operation of machines and tools and to measure and improve their output and efficiency. Mechanical engineering is one of the core disciplines of engineering that dates back to old times. So basically, mechanical engineering is the forefather of all other engineerings. So we have four main branches of mechanical engineering. First is the production, second is the maintenance, third designing, and fourth one is the quality control. So production is the branch of mechanical engineering that deals with the production of pre-designed products. It generally deals with mass and batch production. So we have special skills required, which are great management and good communication skills, deep knowledge of manufacturing processes and machining operations, and it is way easier than designing and QC or quality control. Next is maintenance. It is that branch of mechanical engineering that deals with the maintenance of machines and equipment such that they run with maximum efficiency, minimum pollution, and increased life. So, by its root word to maintain, the engineers maintain the function and the purpose of every device or machine that they produce. They make sure that it works properly, and it gives and provides benefits and a lot of advantages, and it causes no harm to people and everything around that machine. So that's the job of an engineer. It's to maintain. And special skills that are required is higher technical skills related to machines, mechanism, bearing, standards, and cost controlling skills. So the third branch is designing. It is the branch of mechanical engineering that deals with designing of new machines, parts, components, and new and more efficient systems. So basically, for me, designing is the most difficult branch of mechanical engineering, because it is not just the outward appearance that you design, not just the beauty or the overall look of a machine or a product, but you also make sure that every part of it has a significant purpose and of great help for the overall device or machine. So the special skills required are great and deep knowledge of subjects like physics, material science, mechanics, machine design, and calculus. We need material science in order to identify and determine the most suitable material to be used in a certain machine that we are designing. So yeah, and then next is high presentation skills are also required. And also we need to have a background of AutoCAD and a whole lot more. So examples of design products of mechanical engineers and other engineers is like this Apple iPhone. So from the insides of it, how does it works, and up to the outward appearance, they are all little by little assembled and brainstormed by the engineers in order to produce this very efficient phone that we have today. So that's the Apple iPhone. It's very complicated, and you can see all of the functions there, all of the parts are labeled there. So it's very complicated, yet it's very beneficial for all of us. And the last branch of mechanical engineering is the quality control, or the QC. It is a procedure or set of procedures intended to ensure that a manufactured product or performed service adheres to a defined set of quality criteria or meets the requirements of the client or customer. So basically, in simpler terms, quality control, if you're an engineer for this, which is that you are called a QC engineer, you are the one who oversees the production of your devices and the machines or your products, and you make sure that all of your customers, your clients, are satisfied with the outcome or the product that they received. So special skills required for a QC engineer is that you need to have a high knowledge and skills of metrology instrumentation. And then next is external degree and certificates required for radiation, ultrasonic, and non-destructive testing, and a whole lot more. And now let's go to the scopes and jobs related to mechanical engineering. So as you can see here, a mechanical engineer is needed for manufacturing, designing, maintenance, and quality control related to the smallest things such as a pin or a paper clip to the manufacturing, designing, maintenance, and quality control of largest things such as jumbo jets, space shuttles, satellites, and space stations. So every engineer, and especially the mechanical engineer, they are the ones who are in charge of producing, manufacturing, and providing comfort and the needs of the people by doing their best, from the very smallest things like a paperclip up to the greatest machines that we have seen in our lives and we haven't seen yet as well. So the engineers are always in the behind the scenes of it all. We just don't know that everything we see every day, they're all the product of the labors and the knowledge and skills of the engineers. So where can we apply, or what jobs could we apply to if we are a graduate and we have a degree of a Bachelor of Science in Mechanical Engineering? So we could work at any industry. We could join politics, research and development, and we could proceed to graduate school. We could also apply to police stations and military areas or fields. Then technical, sales and marketing. Then education, we could be a teacher, we could be a professor. And then technical consultant, we could be like that. An independent entrepreneur. And engineering, social services. So these are just the fields or areas that a mechanical engineer can apply to. But if we will be very specific, like a job, a mechanical engineer can be a chief engineer in the boat, sa barko bala, na they could proceed to become a seaman, at the chief engineer of the ship, the vessel. And then we could also proceed or get like just how many months of studying for aeronautics. So we could be an engineer also for airplanes and a lot more. A safety engineer who ensures the safety of the people in every company or factory. So mechanical engineering, as what I've said, is the largest or the broadest scope of engineering, that whatever field you come into, if you're a mechanical engineer, you could easily cope up and apply to, because I feel like mechanical engineering is all around. So now let's proceed to the most controversial topic for mechanical engineering students and mechanical engineers. Not just to brag, but in India, way back 2014, their very basic salary, the minimum is 142,290 Indian rupees, and the maximum would be 750,970 Indian rupees. So if we convert it to Philippine peso, today, the minimum salary in India, if you work in India as a Filipino mechanical engineer, you will garner a 95,000 pesos per month, salary per month. So, like in my case, as a student, I have my note in my notebook that today, in the latest survey that we got, according to DOLE, or the Department of Labor and Employment here in our country, the Philippines, the minimum salary of an engineer, if you have just started, is just 14,500 pesos. But that's just the minimum. But you could garner up to 100,000 pesos if you are a professional and a very skilled engineer. So nothing is impossible. So skills that affect mechanical engineers. And also, I forgot, if you apply abroad, you could garner 1,000 of US dollars per month. If you go to US and also to Singapore, you will always receive per month that amount of money. Even if you're just starting and you have few experiences, and then somebody will hire you abroad, you will receive that amount of money. So we also have skills that affect mechanical engineering salary. So if we are very analytical, we have analytic skills, we could have 29% plus for our salary. And if we are a professional engineer, it's a 14% plus. and a whole lot more. And of course, plus points if we know how to use AutoCAD, Microsoft Excel, Microsoft Word, and if also we also have management skills. And yeah. Now let's proceed to the top mechanical engineering companies in the whole world. So first is none other than NASA, Siemens, Larsen, and Turbo. It's all about Imagineering. Okuma, Rolls-Royce. I remember I've seen a car that was designed and manufactured by Rolls-Royce, and I was so amazed of the mechanisms and the design of the car. So imagine if we could be an engineer who could invent and design something extraordinary that every human eye will be amazed. Next is Kirloskar, Godrej, Thermax, Tata, Suzlon, Powering a Greener Tomorrow, SR, Let's Begin, GE Aviation, Ford, the most familiar, Adani, Boeing, and a whole lot more.
So that's it for mechanical engineering. And for those of you who are afraid of math or find math very difficult, I tell you that math is fun, and if you're just diligent enough and have the sense of responsibility, nothing is impossible for you to reach your dreams. And share ko lang, let me tell you my story. Why did I choose mechanical engineering? Because it inspires me that we won't only have the greatest or the biggest salary we could have or receive from big companies, but also being an engineer, you will also benefit other people around you. You work for the greater good of everyone in your society. So you not only help yourself and your family, but you also bless. You extend your blessings to other people as well. So choose mechanical engineering here in STI West Negros University, and we, your manangs and manongs, will help you. We will go all the way through together. Here in STI, the College of Engineering, we leave no one behind. So I hope you choose STI West Negros University when you go to college and choose mechanical engineering. Thank you. Bye. God bless.
So much to our first lecturer. And for our next topic, I know every engineering students, if mabatian nila ang mga subject, some of them ginakulbaan, but I know you're all smart and I know you're all willing to learn. And so with that, let us all welcome our second lecturer for the topic, thermodynamics.
Hello, good day to all my fellow students. We're here once again to tackle about one of the most important subjects in the field of mechanical engineering. This subject is very important because we always see it everywhere. We just don't know, from the air conditionings to the refrigerators, how the cars work, and a lot of things around us. So what I'm talking about is thermodynamics. So we're going to study, or we're going to discover the laws of thermodynamics, the basic concepts of thermodynamics, where can we apply thermodynamics, and a whole lot more. So please stay with me and listen so that we could learn together, okay? So here's our presentation.
So thermodynamics. What is thermodynamics? From the word itself, thermo means heat and dynamics means motion under the action of force. So thermodynamics is the branch of science that deals with heat or work, broadly energy interaction, and related changes in the physical properties of a substance. So in studying thermodynamics, we have two approaches. First is macroscopic approach, and second one is microscopic approach. So for macroscopic, a quantity of matter is taken into action for analysis, and it does not consider matter at molecular level. On the other hand, microscopic, in this approach, analysis is done on molecular level. By adding up the behavior of each molecule, analysis can be done. And for macroscopic again, this kind of approach is made in classical thermodynamics, while microscopic is made in statistical thermodynamics. So what are the basic concepts of thermodynamics? First is a system. It is a region or space for study. As you can see there in the diagram, the system is your chosen area or part that you would like to study. And the surroundings is everything that surrounds that system. So it's external to the system. And number 3, universe. System and surrounding together constitute the universe. So as a whole, it's the universe. And the boundary. System and surrounding is separated by a boundary. As you can see in the picture below, there's a system and there's a boundary that separates the system and surroundings. And outside the system is the surroundings. And the whole of it is the universe. So next are the 3 types of system. First, we have the open system, or also known as the control volume. It has an opening, and both mass and energy can cross the boundary. For example, pumps, compressors, turbines, and heat exchangers. While closed systems, it is literally closed and it doesn't have any opening, so only energy can cross the boundary. For example, refrigerators and AC or air conditioners. So yeah, and meanwhile, isolated system has no transfer of energy and matter across the boundary. So for example, thermoflask and the universe. So what are thermodynamic properties? Properties are used to define the characteristics of a system. For example, pressure, temperature, volume, mass. Thermodynamic properties are mainly divided into 2 classes, the extensive and intensive. Extensive properties are dependent on mass, for example, volume, energy, and enthalpy, while intensive properties are independent of mass. So, example, pressure, temperature, and density. And all specific properties are intensive properties. So, additional concepts for thermodynamics. First is states, or just state. It is a condition or a status of a system described by its properties. And next is process. When a system changes from one state to another, then it is called a process. So whether a system or a thing undergoes a change, it means it is called a process. So we have 2 processes. First is reversible process. It is a process that when reversed does not leave any effect on system and surrounding, or it can go back to its original state. So whether you reverse it or not, the same effect still displays, and it is reversible. While opposite to reversible is the irreversible. That just simply means that a process which cannot be reversed to its original state. And then last is the cycle. It is a sequence of different processes whose initial and final states are the same. So when there are a lot of processes done, that's called the cycle. But all those processes should have the same effects and end results and initial and end results. So thermodynamic equilibrium. A system is said to be in thermodynamic equilibrium if it satisfies the following three conditions. So first, thermal equilibrium, no temperature difference between system and surroundings, while mechanical equilibrium, no unbalanced forces within the system or with the surroundings, and chemical equilibrium, no chemical reaction and no change in chemical composition. So let's proceed now to the applications of thermodynamics. Where can we apply thermodynamics? So first is the human body. We just don't know that there are thermodynamic systems and processes within our body. It is when we intake our food and have our balanced diet, our diet converts into energy, and and that energy transfers to all of our body parts, and that's the reason why we're able to move, we're able to speak, we're able to do our daily activities because of that process. And also we have power plants, car radiators, jet engines, and air conditions, and a whole lot more. So wherever we go, we can always see machines and devices, but we just don't know that behind them are thermodynamic processes. Okay, so lastly, I would like to share the laws of thermodynamics. We have 4 laws. The first law, this is just gonna be an overview. First law is energy is conserved. Its form can be converted. So energy can never be created or destroyed, but it is just conserved and converted or transformed. While the second law, energies can flow and equilibrate. So the third law, driving force for equilibration uniquely defined. And the zeroth law of thermodynamics is that thermal equilibrium is transitive.
So that's all for thermodynamics. Its basic concepts, the laws, applications, and the whole thermodynamics, the general overview of it. So I hope you have received inspiration and knowledge and trivias about thermodynamics. So how important it is and how beneficial people will receive from that study if we apply it to practice, and if we also use it for the greater good for all of us. And if we choose mechanical engineering, this subject is very important. So I just hope that you've learned a lot, and that's it. Thank you. God bless.
Thank you so much. So for our next topic, I know everyone who has interest in electrical engineering will enjoy it. So without further ado, let us all welcome the third speaker or third lecturer in the topic, the electrical safety.
Good day, officers, and especially to our dearest advisor, Sir Antonio Rivera. We are here today to give you some advice and knowledge and background about electrical safety and precaution. Introduction to electrical hazards. Electricity is safe to use but may become dangerous in careless hands. It may cause fire, damage, and fatal or non-fatal accidents to personnel unless appropriate elementary precautions are taken. This danger from electrical can be avoided by using good quality equipment, material, proper wiring insulation, as well as efficient maintenance and upkeep of protective devices. In large factories of power system or other electrical installation, it is not always feasible for engineers and supervisors to explain at length as often as necessary all aspects of safety precaution to every new staff member nor to train him against all possible hazards within a short period of time. It is therefore essential to introduce a safe operational procedure in the form of safety codes. What exactly is meant by electrical accident? Every case where a person receives electrical shock or suffer injuries directly or indirectly in connection with the generation and transmission supply or use of electric energy should be treated as an electrical accident, even though this may not be serious. Again, if a person gets injured due to fall from electrical post, it's better to treat as an electrical accident. Cause of death. Each electrical parameters current, voltage, resistance, time, frequency, and wave from are important determinants of injury, both in their own right by the virtue of their interaction. Cause of electrical hazards. Proper operation of electrical insulation require that machinery, equipment, and electrical circuits and lines to be protected from hazards caused by both internal, arising within the insulation, and external factors. What are what are internal causes? First, overvoltage. Second, short circuit. Third, overcurrent. Fourth, corrosion leading to electrical current leakage to ground. Fifth, heating of conducting and insulating material that may result in operating burns emission of toxic gases, components fire and flammable. What are cause of external causes? First, mechanical factors like fall, bump, and vibration. Second, physical and chemical factors, natural or artificial radiation, extreme temperature, oils, corrosive liquids, and humidity. Third, wind, snowfall, lightning. Fourth, animals in both urban and rural settings may damage the power line insulation and so cause short circuit or false contact. And fifth, and least but not the least, adults and children who are careless, reckless, or ignorant to risk operating procedure. Protection, relay and fuses, earthing, functional group grounding of metal conductors of three-phase system, midpoint of transformer secondary. Protective group grounding all metallic portion. In concluding part, I would like to convey that electrical accident occurred due to the following reason. First, electrical shock. Second, flash. And third, fire. Main points to be checked during annual inspection. Every part of installation should be checked by a responsible officer and preferably recorded in a register or entered in a tabulated form. In brief, this consists of the following instruction. First, service connection. Two, main switchboard. Third, internal wiring and its insulation. Fourth, earth test and bonding. And to continue our discussion, we'd like to call our secretary, Mr. J.B. De La Cruz, to continue this discussion.
Hi guys, my name is JBS De La Cruz. I am the Secretary of Electrical Engineering, and then I would like to thank Albright Sumugat, the business manager, for the discussion earlier. Okay, so this time we will continue our report. In this topic, the title is The Points to be Remembered for Electrical Safety. Okay, so next. First, always use the switch and phase wire instead of a neutral wire. Then, number 2, always use 3-pin plug in socket. Next, number 3, there should be no joints in wire or cables. Next, the number 4, use MCB for overload and short circuit protection at mains and at power point. Okay, and the next, number 5, never touch any electric equipment with wet hands and never touch any electrician working on electrical installations. And the next, number 6, all metallic parts should be properly earthed. Next, number 7, all transformers should be earthed at 4 points. Okay, next, number 8, never shift any running pedestal or table fan. Desert cooler is further dangerous. The next, number 9, always use proper rating of fuses. The next, number 10, always use good insulation wires and good insulation tapes. Also use proper tools. Okay, next. Number 11, there should be no smoking zone near transformer oil. diesel, and electrical equipment. And the next, number 12, there should not be any water or condensate dripping near cables or panel boards. Next, number 13, rubber sheets are must in front of panels, also used while working at its backside. And the next, number 14, sun buckets and fire extinguishers should be placed near electrical panels or installations. Number 15, never use pliers or screwdrivers of poor quality and poor insulations. The next, number 16, never join two wires of different rating. Example, thickness. Okay, and the next, number 17, whenever there is a loose connection, spark will occur due to millivolt drop, which may result in flash, fire, or accident. Number 18, never overload any socket or point. Next, number 19, ensure while digging pits or trenches that cables are not laid in that area. Also think for similar risk while drilling in walls or pillars. And the next, number 20, never keep anything inside or on top of electrical panels. Next, number 21, stagger joints are useful wherever feasible. And the next, number 22, keep the panels closed. And the next, number 23, following precautions are must while switching on or off any domestic switch. Hands should be dry shoes or sandal. Okay, and the next, number 24, electrical work requires full attention all the time. And lastly, the number 25, concentrate on your work to avoid mishap. Okay, so next slide is, now at the end of the session, you have understood the three letters. First is the risk from electricity. Letter B, precautions at home. And then lastly, precautions in factory. And are able to protect yourself. So that's all for today, guys. Thank you so much for watching.
That topic was very interesting. So, I hope you still have all your attentions as we go along our last topic. So, let us all learn about the code of ethics together with our last lecture.
Okay, so good day everyone. So for today's topic, we are going to discuss to you some of the important things we should remember when we talk about a code of ethics, especially in electrical engineering. But first, let me introduce myself. I am Ana Delia Pulin Felicissimo, a Bachelor of Science in Electrical Engineering student, together with my partner, Mr. Edward Inigo. So, let's start. Ethics are very important for electrical engineers. Ethics are something that cannot be taught by teachers but must be learned on your own. You must be the one to teach yourself this important skill. Ethics are the basis for your own confidence as an engineer. Engineers who make the correct ethical decisions are the ones who know what they are doing and correct their mistakes. But unethical and poor engineers are so worried in their performance, where they are forced to cheat, lie, and steal in order to be competent. Cheating can be easy, but doing the work will make you much better engineer in the long run. It is hard to cheat on exams, harder to cheat on projects, and impossible to cheat when you are designing systems never before done. That is why it is necessary to do things the hard way, so you can think of yourself when the time comes. Define what ethics is. An ethics is a set of moral principles or values govern the conduct of an individual belonging to a group or profession on the basis of honesty, fairness, and justice. An electrical engineer should observe a system of moral principles and values not in passive recognition but a set of dynamic standards to guide his conduct and way of life. It is also his duty to practice his profession according to this code of ethics. The keystone of professional conduct is integrity. In line with this code of ethics, we can find the Republic Act No. 7920, an act providing for more responsive and comprehensive regulation for the practice, licensing, and registration of electrical engineers and electricians. The Republic Act No. 7920 is also known as the New Electrical Engineering Law. So for this code of ethics, we can find part of it that discusses how professional an electrical engineer should act. What are the relationship between clients and employers, and also the relationship between fellow engineers. So for the Article 1, which discusses a professional life, Section 1 states that an electrical engineer should discharge his duties with absolute fidelity to his clients and employers, and to act at all times with fairness and impartiality to all, having due regard to public interest and welfare. Section 2, an electrical engineer should uphold the honor and dignity of his profession and therefore should avoid association with any person or enterprise of known questionable character. For the Section 3, an electrical engineer should strive to upgrade his skills and knowledge in electrical engineering in order to give the best possible service to the public, which should be attained by interchanging information and experiences with other engineers, and by unselfishly contributing to the mission of engineering societies, institutes, schools, and engineering and scientific media and other public institutions. Section 4, an electrical engineer should only advertise his work or merit in a simple manner and avoid any practice that will discredit or do injury to the dignity and honor of his profession. So for the Section 5, an electrical engineer should endeavor to extend public knowledge of engineering and shall discourage spreading the untrue, unfair, and exaggerated statements regarding engineering. Section 6 states that an electrical engineer should have due regard at all times for the safety of the life and health of his employees, other workers, as well as the general public, and for the protection that may be affected by the work of his responsibility. Section 7, an electrical engineer should express an opinion on engineering subject, whether publicly or privately, only when such opinion is called for. His opinion must be founded on adequate knowledge and information of the relevant issues and facts based upon his honest convictions. And lastly, for the Section 8 in Article 1, an electrical engineer should not issue statement, criticisms, opinions, arguments, or other views on matter except where public interest is affected. So for the Article 2, the relationship with client and employer, it is to be discussed by Mr. Inigo.
Continue for the Code of Ethics, Board of Electrical Engineer, the Article 2, or the relation with client and employer. For the Article 2, Section 1, an electrical engineer should be fair, impartial, and reasonable in rendering professional service to his clients, employers, and contractors regarding contracts or other agreements. For the Article 2, Section 2, an electrical engineer should, before undertaking any engagement or entering into any contracts which calls for his professional service that will require or need the use of apparatus, other equipment or things in which he has financial interest, have such situation clarified in the contract or agreement to avoid conflict of interest. For the Article 2, Section 3, an electrical engineer should be vigilant in guarding against conditions that may be dangerous or threatening to life, health, or property on work for which he is responsible, or otherwise bring such conditions to the attention of those responsible. For the Article 2, Section 4, an electrical engineer should present clearly the known possible consequences or limitations of the work for which he will be responsible. For the Article 2, Section 5, an electrical engineer should honestly advise his clients or employer to engage the service of other experts and specialists and should cooperate with them in the interest of his client or employer. For the Article 2, Section 6, an electrical engineer should not accept compensation from more than one interested party for the same professional service pertaining to the same work without the consent of all affected parties. For the Article 2, Section 7, an electrical engineer should not divulge confidential matters or information which has come to his knowledge concerning affairs to his client or employers without their consent. Article 2, Section 8, an electrical engineer should not be financially interested in the bids of a contractor on competitive work for which he has been or expects to the consent of his client or employer. Article 2, Section 9, an electrical engineer should promptly disclose to his client or employer interests which he may have in a business that may conflict with or affect his decision regarding engineering work for which he is employed or which he may be called upon to perform. So next is the Article 3, which is the relationship between fellow engineers. For the Article 3, Section 1, an electrical engineer should endeavor at all times to protect the engineering profession collectively and individually against misrepresentation, distortion, misunderstanding, or unfair criticism. For the Article 3, Section 2, an electrical engineer should give credit for the engineering work to the person whom the credit is legally due. For the Article 3, Section 3, an electrical engineer should live up to the standards of professional practice for electrical engineer. Article 3, Section 4, an electrical engineer should not directly or indirectly injure the professional reputation, prospect, or practice of his fellow engineer whenever he finds an engineering violating the rules or of unethical or unprofessional practices. He should not hesitate to bring the matter to the proper forum for disciplinary or for other appropriate action. For Article 3, Section 5, an electrical engineer should not compete with another engineer on the basis of compensation for particular work by means of underbidding after the result of a public bidding are announced.
So why do you think Code of Ethics is important for electrical engineers? It is because of the three main reasons. First, people rely on engineers to provide them with safe and reliable goods and services. Second, engineer must perform under a certain standard of professional behavior which requires adherence to the highest principles of ethical conduct. And lastly, mistakes made by an unethical and or incompetent engineers do not just cost money, but also they could cost many lives. I think that would be all for today. Thank you.
So that's all for today, and I hope you learn and you grasp something that would register in your mind. Kag may hamambal sa yourself nga, okay, I've finally decided kung ano ganang i-take up ko in the near future or mag-college na ko. So thank you so much for joining us today, and I hope you will enjoy the rest of your immersion this school year. And if you have any clarifications or questions, feel free to ask us or send us a message.